I'm going to talk about solving exponential equations. So these are equations that contain exponential functions. So let me give you an example. 2x is equal to 8. What do you suppose x is? All right. You can think about that for a moment if you like. The solution is that x is equal to 3 in this exponential equation. All right? You can find that. You probably found it by trial and error. Let me give you a systematic way to think about how to solve exponential equations at this point. Later we'll learn about a more powerful technique, but for right now, the technique I want to impress upon you is to get the same base on both sides of the equation. I want a single power on each side of the equation, and I want the same base on each side of the equation. So for this, if you were solving it, if you were spelling out what we probably did in our minds, if you solve this, you would have 2 to the x, and then 8, I want to write that with a base of 2. So can you see that I can write that as 2 to the 3? All right. Once you've got a power equal to a power and then the same base on both sides, you know that the exponents have to be the same. So you simply match up the two exponents. X is equal to 3, and there you go. All right. So let that be your guide to solving exponential equations. All right. Now, you may have to sometimes do some manipulations in order to get the same base on both sides. All right. So let me do a few more examples to make that clear. All right. So suppose that we had something like the following. Suppose we had 3x plus 3x plus 3x was equal to 27. All right, so it doesn't look like we've got a single power on each side. All right, and we're adding these pieces, so that's just making things more tricky. Somehow we have to get a single power. So let me show you how I would solve this one. All right, so on the left side, I can write that as 3 times a single power, 3 times 3 to the x. And that's equal to, on the right side, 27, I can write that as 3 cubed. Now, I still don't have simply a power on each side because I'm multiplying the left power by a coefficient. However, I can rewrite 3 as 3 to the 1. And now I can use an exponent rule to write the left side as 3 to the x plus 1. And that's equal to 3 to the 3. All right? So you have to sometimes use the exponential rules that you've learned in order to get a single power on each side with the same base on each side. All right? So finishing this off, now we equate the exponents, and we get x plus 1 equals 3, so x is equal to 2. And you can plug in to the original formula to confirm that indeed that gives the correct answer.